Hey, I'm Drew. I am from Chroma. Let's see, let me do this. Cool. So today I will be showing you guys what we just built, which is an FTP server uh, for querying popular open source code repositories. So what we did is we indexed a bunch of the most popular GitHub repos into Chroma and made them available for you via MCP server for full text search, regex, semantic queries. So I'll show you a little demo and then I'll walk into how it works. So I have Cloud Code here. I've already loaded our tool in, and I have this prompt. Let's say I'm coding and I want to know something about SQL Alchemy. So I ask about SQL Alchemy. So let's see, it's wizarding, and it used web service, web demos. But, I'll try one more time. Okay, we'll give that one more go. Okay, here we go. So this is our tool. And so you can see here that it's doing this hybrid search, which is it's basically doing semantic queries. And then now, it's kind of zeroed in where in the code base you need to go. And now it's doing this more precise grep search. So it's going to perform like a regex query. And then it'll keep going as Cloud Code does until it arrives at a reasonable answer. One other thing that we're doing is we've indexed like .md files, and then we plan to index documentation as well. So it'll have access to the kind of full suite of things. So there we go. So now you can see that you can get a much better result about your dependencies versus kind of model hallucinating things that up to its training data cutoff. So I'll dive into how it works, how we did this. So here's like kind of a little overview. There's a lot of moving parts that went into making this happen. I'll try to talk about the things that I think you all will find most interesting. But basically, we have this whole pipeline that gets everything into Chroma. So we have a poller that is constantly polling GitHub for new versions of packages. We have a queuing system that then a dispatcher picks up and sent off to a fleet of indexing pods. And then to get them into Chroma, we run inference to embed all this code using Quen models, and then send it into Chroma, and then expose it via MCP server to you. So the things that I can talk about the indexing pipeline. It's a lot of distributed systems fun, but I think what might be more interesting is kind of the tool design of the MCP server. So we kind of started and iterated on this a little bit, starting with one tool that we had kind of everything in, and it was extremely expressive, kind of using like the Chroma like query language and doing like choosing whether to do regex or semantic search. And we realized that like models didn't have didn't know the right way to call the tool, both semantically and syntactically. And so, after many iterations of this, we learned that semantic search, as you saw, is kind of very good for localizing into a code base. But then grep is really what you want for finding that exact thing that you're looking for. So it led us to split into using two separate tools. So the first one you can see here is package search hybrid. So it uses semantic understanding, and this is kind of the prompt we use for the model. And then we have here we have package search grep, which is kind of more the like precise regex queries. So that's kind of one learning that we had. Second was that we realized that we were bloating the context a lot. And so we condition the model with like examples and then prompts on when to use which tool when. And in the future, we might even go further and like use a sub agent to kind of cut down the context and just give that like exact, precise file you're looking for.
You got 5 minutes of questions. I would love to see how you are being sparse with what comes into the context. How did you make the responses more context efficient?
You mean from when we
Yeah, like what changed it?
mainly was splitting it into these two tools. So before it was like we were like, okay, find this, use Chroma, and then it would like use a very expressive like set of filters or semantic queries, and it would just like return a whole dump of things. So what made us like kind of cut down the context quite a bit from the first iteration was actually splitting into these two different tools, telling it when to use semantic and then when to use a route.